morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. We're getting closer and closer to fine, as indicated by the Indigo Girls. Closer to fine because we are on our final video discussing argument and polar form. Let's get to it, shall we? Just a couple of more examples, and here we go. So they want us to use complex numbers to write cosine 7 pi over 12 and sine 7 pi over 12 in simplest surd form. That is simplest radical form. Because right now, we can't do it. We don't know what the cosine of 7 pi over 12 is or the sine of 7 pi over 12 is. Because it's not one of our main unit circle values. Say yes? Yes, right? But we can do this. Ready? Let's consider cosine of 7 pi over 12 plus I sine 7 pi over 12, which is equal to cis of 7 pi over 12, which is equal to cis of, and now is where things get cool, 3 pi over 12 plus 4 pi over 12. Why did I choose those? If you don't know, I'm a little annoyed. 3 pi over 12 is pi over 3, 4 pi, or pi over 4, 4 pi over 12 is pi over 3, and we know the cosine and sine of those, and if you don't, I don't want to know about it, and you better find out. Well, that is equal to cis pi over 4, 3 pi over 12, times cis pi over 3, 4 pi over 12. Why? Because of this little doohickey right here. Well, this is fabulous news because now I can write this as 1 over root 2 plus 1 over, oops, that's a square root, 1 over root 2i. Don't tell me if you don't know why. Cosine of pi over 4 sine pi over 2, pi over 4 is 1 over root 2 or root 2 over 2, depending on your preference, doesn't really matter. Cis pi over 3, if you do not immediately know that cosine of pi over 3 is 1/2, shame on you. You were not closer to fine. Plus root 3 over, you're closer to failure. I mean, let's be honest. Okay, so if we expand that and gather terms that do not involve I, we end up with 1 over 2 root 2 minus root 3 over 2 root 2 plus I times root 3 over 2 root 2 plus 1 over 2 root 2. Giddy up, right? Well, what good does that do us? Boys and girls, looky here. All of this is equal, yes? Cosine 7 pi over 12 plus I sine 7 pi over 12. So if we equate these guys, cosine 7 pi over 12 must be equal to this, yes? And I sine 7 pi over 12 must be equal to this, correct? So let's take this guy and we'll work out cosine 7 pi over 12. Yes, is going to be equal to 1 minus root 3 over, that's a 3, over 2 root 2. Say yes. And if I rationalize the denominator to get in simplest third term, I'm going to multiply by root 2 over root 2. And that becomes root 2 minus root 6 over 2. Booyah! And then sine 7 pi over 12 must be equal to root 3 plus 1 over 2 root 2. Isn't life glorious? Yes? And same thing, I'm going to rationalize. Yes, and that gives me root 6 plus root 2 over 4. So we have used complex numbers to write these impossible values for cosine and sine in simplest radical form. Love it. Moving on. Suppose z equals root 2 cis theta, where theta is obtuse. Find the modulus and argument of 2z or not 2z. So let's take a look at A. Okay, so 2z is going to equal 2 root 2 cis theta. Yes? 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 So that means mod of 2z must be equal to 2 root 2. Remember? Because this is of the form mod or r cis theta. Yes, it's in polar form, and r is equal to mod z. Yes, whatever the complex number is. And our z is actually 2z in this case. All right, B. Ready? How about z over I? Don't be afraid. Don't be afraid. Now recall, I equals cis of pi over 2. Remember? Because this is really 0 plus I. Yes, and if we graph that, it's going to look like this, isn't it? So the argument here has to be pi over 2. Okay, real, imaginary. My real value is 0, and my imaginary value is I. So this is just 1 right here. Okay, no big whoop. So that means that z over I must be equal to root 2 cis theta over cis pi over 2. Yes? And that is equal to, what's cis pi over 2? Well, that would be 0 plus, what, sine of pi over 2 is 1, so I, right? So that turns into root 2 cis, well, actually, I don't even have to think about it like that. I'm going to use the property of cis, and remember, cis theta over cis pi over 2 is equal to theta minus pi over 2. Okay, so all I have to do is get this in polar form, and I have, my arg here is theta, sorry. Arg is equal to theta, right there, right? So mod z over I is equal to root 2, and the argument is equal to theta minus pi over 2. Bam! And this is cool because theta is obtuse and theta minus pi over 2 is within the accepted domain of the argument from negative pi to pi. Giddy up. What about C? All right, so 1 minus I times z. Are you with me? Good. Let's think about this. Where is 1 minus I? 1 minus I, yes? So that's right here. So this is going to be negative pi over 4, clearly. Okay. So we know that 1 minus I in polar form is equal to root 2 cis negative pi over 4. Okay. Why is that? Well, mod of 1 minus I is root 2, and we just saw where the argument is negative pi over 4. Okay? And so if I take that cowboy times z, 1 minus I times z, what do I end up with? Well, I get root 2 cis negative pi over 4. Can I do it? Let's see. Times, and z is root 2 cis theta. Root 2 cis theta. Ooh, ooh. I'm a bad man. All right, so what does that become? equals, well, root 2 times root 2 is 2. And by property of cis, I can rewrite cis negative pi over 4 cis theta as cis negative pi over 4 plus theta. So we are in business, right? So that means that mod of 1 minus I z is equal to, oops, what did I need the modulus symbol, is equal to 2. And erg of 1 minus I z is equal to theta minus pi over 4. Giddy up. Okay? So good, so fun, so fun, so good. All right, get on your thinking caps, boys and girls. So maybe let's see if this will work out for me. All right, did I do 2 of them? I think I did. It's not reacting like I want it to. Come on, computer. All right. Okay, suppose z equals cis phi. Yes, where phi is acute. Find the modulus and argument of z plus 1. All right, well, we know that if z equals cis phi, yes, then the modulus of z is equal to 1. Okay? And, oh, this is phi. Sorry. No offense. Mod z is equal to 1 because the coefficient here is 1. And the argument is phi, and phi is acute, so it's somewhere in here. So let's say, 1, 2, 3, 4. Let's say that this is 1. Okay? 2, 3, 4, 5, and that this is 1. Okay? So if you can imagine the unit circle here, or part of it, then, I don't know, let's say this is phi right here. It's acute, yes, so it could be anywhere. And we know that this is equal to 1, correct? So to get here, to get to this point, I had to go, this is also equal to a plus bi. Bear with me, yes. So I had to go to, let's say here, yes, a, and then up b to get to here, right? A, b, okay? So now, let's consider where z plus 1 would be, okay? So z plus 1 would be equivalent to a plus bi plus 1, which would be a plus 1 plus bi. Are you with me? So to plot this point, I would go a and then over 1, 1, 2, 3, 4, 5, and up to b. Say yes? Say yes? Okay. So we would have this, and this length must be 1, and this length is 1. All right, so this would be r plus 1. Okay, I'm sorry, z plus 1. Sorry, z plus 1. Yes? Makes sense? It should. Okay? And so if I continue this and make a parallelogram here, this is 1. And then this must be 1 because this is parallel to this. So what I have here is a rhombus. I have a nifty rhombus, and I'm going to go ahead and redraw it out here for you. Oh, that is not a good rhombus. Bear with me. So right here, and I know I'm going long. Sorry. Okay, 1, 1, 1, 1. Let's call this M, and we know those are perpendicular. And this is going to be phi over 2 because the diagonals bisect the angles of the rhombus. This is Z, and then this whole thing, if I call this B, A, C, and this is the origin, OB is z plus 1. It's this guy right here. Okay? So, we have a rhombus. So now we know that arg of z plus 1 is equal to phi over 2 because the diagonal of a rhombus bisects the angle, and the original angle we labeled as phi right here. Yes. And we also know that the cosine of phi over 2 by right triangle trigonometry is equal to OM over 1. Yes? So that means that OM equals cosine of phi over 2. Yes? So that means that OB equals 2 cosine of phi over 2. Okay, so I have my argument, and now I have my modulus of z plus 1 because OB is z plus 1. So that means mod z plus 1 is equal to the length. Now the length of OB is this whole thing, 2 cosine. Oops, not linear, of phi over 2. I keep doing theta. So phi over 2. All right. I'm just going to go to this next page. I'm going to get rid of these. It's, just take a quick look if you need to. Well, no, you should take a quick look. There's really no explanation that is necessary here. I also put it on the calculator because I wanted to show you that I is located right here on your pi button. So pause if you need to take a look at these guys, and that is going to be it for me. We are done. Sorry for going over. We will end with the great Indigo Girls, and I do feel closer to fine.